Hello everybody, Brad the Guitarologist here. In this video we are going to take a look at this little bad boy. It is, my wife just snorted. Jesus. This little bastard. We're going to look at this little bastard. This is a 1950 Webster Chicago model 166-1. And what this is a little 10-inch combo amplifier that has two channels. One of them is designated for phono and the other is designated for microphone. So this is the kind of thing, and there's a tone knob as well with the on-off switch on it. So this is the kind of thing probably they would have, you know, had at the fish fry or something, or the town gathering, if they had a politician speaking, and or, you know, maybe a band, and then they had to play music in between changes or something, like, you know what I mean? Little get-togethers. I don't even know what my wife's talking about back there. She's opening her mouth, and this isn't her video, so maybe she should just shut it. Anyway, this is model 166-1. I don't know what the hell that RMA 375 is all about. I can't recall. I have, if you guys will recall, I've had a Webster Chicago on my channel before, but that was that wire recorder. I think it was 1947 or 48, something like that, wire recorder that I converted into a cool little guitar amp. I'll post a link to that at the end of this video if you want to check that out as well, which I encourage you to do. It's like a two-part series, so you'll have to buckle up for that one. But it is a cool little thing, and this is built very similarly. You're actually seeing this after the fact. I've already serviced this, and that's why it has a 3-prong cord, but we're missing the little door here, and you'll see what kind of shape it was in when I got this thing, and it was pretty sorry state. It did work, but it needed some help. The input was already changed to that 1/4 inch right there, but originally it would have had like a 3-prong input. One of them was for common ground, and the other two were for the two channels. Were for the hot leads on the, you know, the two channels. So anyway, neat little thing, and need a lot of work. So stick around, and we'll get into it. Okay, here's this thing up on the bench, and we're gonna have to remove this whole back part. There was some kind of door here that's missing, and I don't know what the hell this is. Again, somebody's already tried to convert this and turn it into a guitar amp, so that part is at least done for us. But yeah, I guess we'll just have to take this out and go from there. We have the chassis out of this cabinet, so we can get a little bit of a closer look at the cabinet. And the screws are held in here with some kind of little rivet that reminds me of a, let me see if I can get a good shot of one. There we go. Reminds me of something you would see like on Levi's jeans or something. But you can see the rivets go through, and they're actually tapped for screws. So that's interesting. Here's the speaker, and we can glean from the code. Manufacturer looks like 232-023, so that'd be probably 1950, the 23rd week. And I would say that's most likely the original speaker. 10 inches by the look of it. Over here we have a little tag. Let's see what all information we have on this. This is what does that say? Model 166-1 D&D. Production number 375025. So 375 must be the code, the EIA code for Webster Chicago, I would guess. And the 0 is 1950, 25th week. And there's the remainder of the information there. Sorry it's upside down, but I didn't make it. Cool that it still has that tag. But you can see how the cabinet's put together. It's not like it's finger jointed or anything. But it is all solid wood. or at least rather not solid, but ply. See by the edge right there. So yeah, let's crack this open. It looks like we have some screws on the outside of the chassis we'll need to get off. We have a couple of nuts here to disconnect the speaker, and it looks like this extra wire is a speaker out. That's what that is. So that's, yeah, this thing that is running to the speaker. Alright, I've removed this cage thing that goes on here and protects the tubes from behind. And I guess prevents you from reaching around and grabbing the innards. And speaking of which, here those are. Let's get some light on the situation. All original caps. I'm fairly certain those Sangamos right there are probably not so good. Those mighty midgets right there are probably not so good. We will go ahead and fire this thing up just for the hell of it, just for shits and giggles. Why not? Tell you what, let's grab some gator clips and clip the speaker back onto it. Fire it up slowly on the Variac and see what it does. All right, let's put some fire to this thing. We'll dial it up on the Variac. And just see if anything happens. There's a little something. There we go. Oh. Not sounding particularly healthy. Now we've got some DC on this this pot right here. So we definitely have some, at least one bad cap, and I'd say the rest of them are bad too. Listen to that. Ugh. I'd say we either got some DC on that pot right there, or it's just really dirty. Could be a little bit of both. Okay, so basically that's almost cranked. I can't crank it all the way up because there's a dead spot right there on that pot. The tone's cranked all the way up. The phono, I don't think does anything. So that the phono is a separate channel that's just not being used. This thing does have two 6v6s for the output. They are labeled Kenrad and they are from 1950. I'll show you all the codes and everything. Okay, just as a for instance, you see this little red capacitor right down here? Measure on one side of that. And you see we have, whoop. Try that again. We have 125 volts on one side of it. On the other side of it, which is on the tone pot, we have 118 volts. So this is doing absolutely nothing. 131. 3 volts there on this other side of that, which is leaky. This one, let's see, 1.3 volts on the other side of it, so it's leaky. You know, these two capacitors for sure are leaky, and if those are leaky, that one's leaky as well. It is only in the tone circuit, I think, but we're going to replace it anyway. We'll just shotgun those Sangamos, and that one right there is way bad. So let's shotgun these capacitors. But before we do that, let's actually see if we can find a schematic, and we'll see what the schematic kind of looks like, and just sort of get a sense of where we need to go with this, because we may change some of these values on these capacitors as we're changing them, so it would be helpful to go ahead and just dig up a schematic. Okay, cool. Apparently Sam's produced a photo fact on this amplifier. Let's see, this one is from 1952, but it does have the 6AT6, 12AX7, and 6V6. What we're probably going to do is look into ways to improve this front end right here, because I would imagine they're not making the most use of this as far as guitar is concerned. So we'll look at options on this front end. Might also look at options on what to do with this phase inverter. Is this thing cathode biased or no? One cathode's tied to one side of the speaker, and the other cathode's tied to the other side of the speaker. And the secondary is center tapped. The secondary of the output transformer is center tapped, and it's biased here. That's just freaking odd. Are they doing that to try to keep the output clean? That's probably what they're doing. Okay, we need to do something different with that. That's just freaking odd. Definitely not something you ever see in guitar amp. Right there. That's a new one on me. So the cathodes, and see this one up here too. The cathode tied to this side. This cathode tied to this side with a center tap. And this is your bias right here. So it is cathode bias, but just weird. Yeah, and we'll definitely look into doing something different with this input, perhaps. We'll just kind of think about options. A 6AT6 is actually a triode with what, a couple of diodes in there as well. So that's just a kind of an inappropriate tube, really. They may have had just a plethora of these tubes. All right, there's the 6AT6 up front. That's a little 7-pin miniature tube right there. And one thing we could do if we wanted to get more gain out of this and not modify it is to simply change that to a V6. That would actually up the gain factor a bit on that stage, but it would still be a triode. So instead of doing that, what we're going to do is explore what kind of pentodes we might convert this to instead. So the 6AU6 is probably the first tube I would think of when I thought of a pentode, a 7-pin. And this one would definitely do the trick, and we may do this, or we may also try a 6BA6, which is very, very similar. They do have the same pin out as well, so we'll be able to experiment after the fact with anything with a 7BK pin out, which is going to give us some options. Okay, here's the cross-reference in the back of the book, 7BK pin out. Lots of options. In the 6-volt range, we have a 6AH6, a 6AK6, AU6, BA6, BD6, HR6, HS6. So quite a few that we could try there that might give us some slightly different characteristics. Alright, since I've pretty much decided already to change this to a pentode input, I'm going to yank this tube out of here, and I'm just going to start clipping leads and preparing this socket to be rewired. Alright, this is pretty much the guitar amp equivalent of the demolition process that you see on those home makeover shows. So we're just basically going to come in here and redo everything. So let's get rid of that. Let's get rid of all of this stuff. Basically anything that's attached to this first socket we're going to remove. Okay, in our new design, this phono control is going to be doing pretty much nothing. At least I think it's going to be doing nothing. So the stuff that's going to it we can actually get rid of as well, and that's just going to prevent some confusion. So basically we can take everything off of that. Alright, the idea here is just to clean up everything and make everything a little bit easier to get to while we're at it. And look at that. Look at that right there. Let's see if we can zoom in on that. See if you see what I see. Once again, look at that connection. Not even on there. It's not even soldered. So how was that working? That was the tone control as well. So that definitely was in circuit. Interesting. Okay, I think what we're going to do essentially here is turn this thing into a Fender 5E3 Deluxe, more or less. Everything from the phase inverter, or the second stage, and the phase inverter onward will end up being a 5E3. Right now we have kind of a weird phase inverter going. We have a paraphase inverter, which is using up the entire 12AX7, and we're basically lacking a gain stage that we could be using. So I'm gonna turn it into a cathode phase inverter, just like this Deluxe. That's going to free up one half of the 12AX7 as a second gain stage, and the first gain stage, rather than being like a 12AY7 or a 12AX7, which is a triode, it's going to be a pentode, which is going to hopefully have a bit more gain, a bit more clarity, probably a bit more singy lead tone, and some even order harmonics if we can bring those out. Okay, so that means it's back to demolition. So basically we're going to start removing these Sangamo caps, and I'm going to leave as much lead as I can because we might be able to tie off of that extra lead. Also, that's going to tell me where that cap used to go, and it just makes things a little bit easier when we're just kind of looking in here. It's also going to make it easier for us to go ahead and get the new power capacitors in here, which we are going to have to put inside the amp and kind of tucking under things because they were outside of the amp in the can up here. So let's go ahead and get rid of this can as well. We'll just clip all this crap out. We won't need any of it. Yeah, man, you see these speaker leads that I took off earlier? They are indeed going to the cathodes of each one of these tubes, and the cathodes are also tied to the secondary of the output. And then we have the center tap, which is this green wire right here. That's going over here where we have the 10 microfarad and I guess it's a 200 ohm bias resistor coming off of there. So just a whacked out way to wire the output. So we're gonna clean that up and fix that. We're gonna clip this center tap because we won't need it, and we're going to loosen these wires, and these wires will basically take the place of these wires. We will no longer need these. Alright, now we'll clip out the power cord and death cap. No need to have this in here taking up space. On this center tap, I'm just going to clip this thing back because we are not going to use a center tap on the secondary of the output. It's just a useless feature. I'll leave a little bit in case someone ever wants to come in here and return this to stock, which I don't foresee ever happening. I see no reason why anyone would ever want to do it. We'll clip it and leave a little bit, so if somebody wanted to do it, there's enough there to do it with. This soldering iron means business, by the way. It doesn't fuck around. Now, pieces of cloth wiring like this, I do not throw away because you never know when you're going to need a piece of cloth wiring to match something in a vintage amp. So I set these aside usually and keep those just for a rainy day. I've got a lot of little pieces like that, and you always end up using them. Let's see this green wire now. The cathode bias resistor down here, I don't know if you can see it or not. It's right in here. It's one of those ohmite style resistors, one of the larger ones, and it's 200 ohms. The Fender Deluxe calls for 250 ohms, but I'm going to leave this 200 ohm in. Okay, that red capacitor right there, that Sangamo that I clipped out, that was the death capacitor. There's actually another one up in there coming off the same point, and if I follow that other wire up, that's going to the mains cord and out. And this thing, I looked, and this thing actually does have two death capacitors, a .015 and a .015 from each side of the line to ground. So this one has double the death. It's mega death. The other thing I noticed about this 120 volt primary is that there's no fuse. So not only is this double death or mega death, this is Google death. Alright, we're kind of working backwards here. I've got the output stuff taken care of. That's this transformer. Bias the output tubes the way we want them. Now I'm going to basically be working backwards back toward the phase inverter, and I'll also go ahead and put the power capacitors right while we're at it. So we're kind of working an ass backwards way, but the hope is we can get these power capacitors in and kind of down out of the way. Then we can tackle the input once we know how much space these are going to have to take up. Actually, I've changed my mind again. I'm going to come in here on this 12AX7, and since we're going to practically completely rewire it anyway, I'm going to basically undo all of the wires except for the input on pin 2. We can leave that one, and the filament wires. Alright, I've changed my mind again, and rather than modeling the output after a 5E3 Deluxe, I'm going to go with something more like the Silvertone 1482. The reason is I'd like the 1482 tone better than the 5E3. That's just a personal opinion, but I think it happens to be also the correct one. So what we're going to do, we're just going to model it roughly after this. So I'm going to change these to a 330K rather than the 220s. And the big difference is going to be this 0.01 capacitor right here and the lack of a grid stopping resistor into the next stage. What that's going to do is it's going to accentuate more highs and more mid-range in the output rather than a kind of a bassy, Fendery sort of tone. It's going to be a little more growly and gritty and a little more Marshall-y, like the 1482 normally is. Another thing the 1482 does is it omits the bypass capacitor right here on this stage, this 12AX7 stage, which is the second stage. The 5E3 second stage has a 25 microfarad capacitor. It's also biased a little bit differently. So on this stage also, we are going to model a little more closely after the 1482. Well, it's no real surprise with all the other funky design features of this amp that it would do something like this with the tone knob. Here's the tone control. It's actually after the phase inverter, and what it seems to be doing is going from the plate of one side of the phase inverter to the plate of the other, and it's putting basically a variable resistor and a capacitor in series between the two plates of the phase inverter, which is odd. It's effective, it works, but it's just an odd way of doing it. This is more closely resembles something like an old 50s PA or 40s PA would have on it, rather than something, you know, for a guitar. So needless to say, we're clipping that capacitor out of there, and we're going to do something different with the tone control. Okay, it's a new day, and I've gotten a lot of work done, as you can see. A lot of components replaced. Basically, this is almost a top-down rebuild, really. All of the capacitors have been replaced except for this one here, and interestingly, this amp has a Zobel network on the output. That is a capacitor and resistor in series across the primary winding of the output transformer. That's what's called a Zobel network, and they were used in Hammond organs and a few other PA systems from the 40s, 50s, and probably early 60s as well. And it's a concept that was kind of stolen by Dr. Z here more recently, and it just kind of pads the output, essentially, is what it does. Prevents spiking. So I'm going to actually leave that, and we'll see how it goes, and if it seems like the amp doesn't need it, or if it's not doing it any favors, then we will think about removing it. But like I said, yeah, pretty much entirely in the process of being rewired. We do still have to rewire that input stage right there, so let's get to it. Alright, in order to design our 6AU6 preamp stage, we're going to kind of get some clues from existing preamps which use 6AU6 tubes. Here's one example. It's just a random schematic that I found on the net. Nothing special, but this is just kind of emblematic of some of the values we might see and some of the design features we might see. Obviously, on the input, we are going to need some kind of reference to ground, such as a 1 meg resistor, so we already know that. We could also add a capacitor here, as well as a grid stopper. Some kind of grid stopper we're going to need, something like 33 to 68, somewhere in there. Also, we'll notice that this grid up here is tied to the cathode. Grid 2 is tied to the cathode. That's the screen. It's going to need its own supply, power supply. This grid is, and also it is helpful usually in terms of gain to also tie grid 2 to the cathode via a small capacitor. So we will probably do that as well. And again, these values aren't going to mean a whole lot because we're going to play with some of these values. This 1.8 meg is probably not anything like we're going to use, and this 5.6 meg is definitely not anything like we're going to use. This is 400 volts up here, and they're trying to get it down to 93 volts. That's why that's so big. But anywhere between 100 volts to 150 volts on the plate should get us about where we need to be. So something like, I think in our design, something like the value that we're using on V2, something like 68K maybe to 100K might be good. We'll kind of play with it once again and see. In this example, they're using a DC coupled stage following this, so obviously we're going to need some kind of capacitor in our design. between there and the next stage. So, but anyway, you know, that's going to give us some kind of direction to go from. Just gives us a loose sort of idea. All right, we're going to start wiring up this input pentode now. And anytime you have a situation where you are wiring something up and you're kind of designing on the fly also, you don't want to just start sticking values in here necessarily without having a good idea of where to start. And the best thing to do is to begin with what you know. We know we're going to need a filament supply, so we've got the filaments hooked up. We also know that this suppressor grid is going to have to be tied to the cathode. So pin 2 and pin 7 are going to have to be tied together with pretty much a straight piece of wire. So we'll put the straight piece of wire in there also, and then begin from there. In the process of preparing these pins on this socket to have it rewired, I actually broke off a couple of these. They're pretty thin metal, and they just basically gave up the ghost. So I didn't have really much to solder to here, and I didn't have much to solder to here either. So what I did was wrapped it around, squeezed it taut, and then soldered. Over here, wrapped around, squeezed taut, and soldered, but left enough where I can actually wind a little loop around to give me something to solder to. So that's where my cathode bias resistor and stuff will go. While I'm thinking about it, I get emails and messages every day asking me about how to get started doing this type of thing and what tools you need or what books you need and all that sort of thing. This is one of the #1 books you can possibly purchase. This is the RCA Receiving Tube Manual. It's got data on almost all of the main tubes that you're going to use in guitar amplifiers. Got a lot of example schematics, and if you want to get into radios and television servicing even, do vintage televisions, you can, using a lot of the data that's in here. Really, this should be your #1 book that you buy. In the description to this video, and probably all future videos for that matter, I'll put a link to a kit.com group of products that I recommend that you can get started with, and it's basically the bare minimum of stuff you're going to need to get started. So feel free to click through that and peruse that if you're interested in getting started on guitar amp repair. Alright, here we're about to solder in our 1 meg grid leak resistor and also our 47K grid stopper on the input. Always wrap your lead around whatever it is you're soldering to, where possible. Sometimes, you know, some rules are made to be broken. Sometimes it's not possible to get a lead wrapped around, or in this case, if you think you might do some experimentation, it might be wise of me to actually just stick it on there, and that way I wouldn't have to take it off. But I think at least this one should be a fine value, so I have no qualms about going ahead and soldering this one on. Okay, so there's our grid stopper installed. Here's one good example of how an RCA receiving tube manual can come in pretty handy. For the tube we're working with here, the 6AU6, you don't have a whole lot of guitar amps that use a 6AU6. In fact, this is going to be fairly novel in the world of guitar amps. I've used it before in a guitar amp, but for this particular amp, we're going to special design something. So what we do is we look here in the under the 6AU6 when we read all the notes for this, and it says for typical operation as a resistance coupled amplifier, refer to resistance coupled amplifier section. If we look in the index, and we'll say, okay, well, where's the resistance coupled amplifier section? We look here, resistance coupled amplifiers, page 26 and page 641. It talks about it. On page 641, there we go. Here's the resistance coupled amplifier section right here, where it talks just in general about resistance coupled amplifiers, the suitable tubes that you can use. Here are the tube types and the associated charts that you need to refer to for each type of tube. The tube we're using is a 6AU6, so we're going to go to chart number 2. So we flip over here. This is going to give us just some general information about triodes, tetrodes, and pentodes. Pentodes is what we're most concerned with, and under pentodes here, it gives us a nice little schematic with just some blank generic stand-in values, CK, RK. That's the cathode resistor. The K is cathode. Cathode capacitor. This will be the grid 2 capacitor, for instance, and so on and so forth. The RP is the plate resistor, so that's a big value we're going to have to choose. This C is going to be a big value we'll have to choose. If we refer to chart 2, which is on the next page, here we go, 3AU6, 4AU6, 6AU6, and 12AU6. So this is the whole AU6 family right here. So for instance, if we want to select a plate resistor, this is going for each plate resistor here. This is going to be 0.22. These are in megs, so that's 0.2 meg. That's 1 meg, for instance. It gives you the rest of the values that you're gonna get for each of these. So this might be a helpful chart for what we're doing here, and that's just one of the ways that an RCA tube manual can help you out. Okay, I fired the amp back up again on the Variac just to see the voltage that we have to work with at the node we're going to have to use to power this new input stage. And the voltage, it looks like when we're at full 119 volts on the input, is going to be about 170 volts. So that gives us a starting point from that we can kind of look at. If we know our voltage that's coming into that stage, we can calculate all the other components that we're going to need. Another thing we can calculate here just from this is the current draw. So 0.49 amps, and that's going to give us pretty much a good value for our fuse that we had to add, this little inline fuse holder. And I've got a 0.63 amp fuse in there right now, and that's the working amps. So anything 0.6 amps and below, we're good, and this looks like that's about what that wants to run at, so about a half an amp. Another thing we can tell here while we have the amp going is whether or not the stages that are hooked up are working. And they definitely are. Also, the longer this has sat, the voltage has crept up just a little bit to about 180, so 180 is a good place to start working from. Okay, so if we refer back to this handy chart, this 180 is the voltage. I mean, how handy is that? 180 is the voltage we're seeing at that node, so this is the part of the chart we're going to use, and it's dead on. So we can pretty much plug in these values. So 1, and that's if we want the maximum voltage gain out of this stage. That VG is voltage gain, so it gives you the voltage gain, the end result for each set of values that you plug in to that stage. So with 180 volts input, if we use a 1 meg plate resistor, we can go right through and use a 2.2 meg, what is that, grid resistor, and so forth. So we just plug in these values all the way down. Okay, the amp is now off, but because we've had it on and we've actually, redone these capacitors, there's a little bit of voltage left in them. So we're going to take a gator clip it to ground, just anywhere on the chassis, and then on the other end of the gator clip we're going to use like just a big resistor, anything, this one's 100 ohms, but just about anything would work. But we just want to touch it to each of these nodes, and you'll see it as soon as you touch it to it, it bleeds it down, down, down. One thing I forgot to do, I forgot to add another resistor and power capacitor that will feed this tube. Now, the thing is, that's going to drop down our 180 volts just slightly, not by a whole lot, but we can still use the values that we saw in the book. That'll still be fine, the values. However, we're going to have to find a place to tie that node onto, and probably our best bet is one of these empty pins. Looks like maybe pin 2 or pin 7 on this rectifier tube socket. So, alright, back to our trusty RCA manual. The 5Y3 rectifier has no connection at pin 1, pin 3, pin 7, and pin 5. Now pin 5 and pin 3 I think are already being used in the manner I intend to use 1 or 7. Now what we want to do is just make sure that, now this is a 5T connection, you see right there, that's a 5T diagram, so anything with a 5T is going to work in this socket. So that includes the 5V4, I believe. No, excuse me, that's a 5L. That one will also work though. The 5V3 will work. The 5U4 will work. And what I want to be able to do is make it so that the 5AR4 or GZ34, which is also a popular rectifier, will also work. But it looks like here we have an IC. That means internally connected. I don't know what pin 1 would be internally connected to, but basically that's going to preclude us from using pin 1. So pin 7 it is, which is really more convenient anyway because it's closer to where we need to come from, which is right here. We need to put our dropping resistor, probably 100K, from right here over to right here, and then we need to put a 10 microfarad capacitor from here to ground somewhere, and then we need to come off of this node and feed this tube with our plate resistor. Just like that. I've got a 1K resistor actually instead of 100K dropping. Here's our 10 microfarad capacitor from that node doing the filtering, and then we have a plate resistor here supplying voltage to this tube. It's kind of like creating a blood supply, something you can sort of think of it like that. And now we need to feed some blood to grid 2, and grid 2 resistor for this supply needs to be about 2.7 meg. It's going to have the voltage needs to be lower on grid 2 on the screen grid than it is on the plate, and 2.7 meg will accomplish that. Okay, the wiring is, I believe, complete on this thing. Once again, for this input stage, I just followed the advice of the RCA receiving tube manual. So if it doesn't work, we will blame it on RCA. Also changed the little capacitor in the Zobel network because that was the only Sangamo original capacitor left, and I thought, why the hell not, especially since that spot sees the highest voltages of any of the rest of them. That one was probably also bad. Got the tone knob wired up. This is doing nothing, so if we wanted to do some kind of future mod or something to this thing, there's an extra spot right there where that potentiometer used to be. I suppose it could be something, like a negative feedback or something like that. And it still might, after we fire this thing up, if I feel like it needs a negative feedback control or something of the sort, we might install that. Here's all the casualties of war down here, and talk about rewiring an amplifier completely. All of this crap was at one point up inside of there. Okay, have this thing plugged in, ready for the first test. We're going to dial it up on the Variac right now. We're monitoring the voltage right here on the last node that we created for the V1 tube. And let's see what she does. She may just scream at us. Yeah, see, that needs to be cleaned in a bad way. Still, whoops. Let's see. Got a lot of stuff sitting on top of the cabinet. Hang on, I gotta take care of that. There we go. I took some stuff off the top of the cabinet. It was rattling around, and plus tightened up the handle mounts. And let's see what it does now. That's halfway up on the volume. Okay. Definitely still have some problems with the tone. Hear that microphonics right there? That could be this tube. Getting some weird oscillations, and I think it might be related to one of these. Could be related to one of these pots being bad. I'm not sure. It could also be that some spray was still inside the pot, because I did just spray it. Still got some work to do. Okay, I've been testing out several different tubes in the V1 position on this amplifier, and one thing is clear, that 6AU6 tube has a tendency to be microphonic, so you're going to have to do some selecting to get one that's not microphonic and that won't make noise and cause oscillations and issues in an amp like this. I don't know if that's typical of these tubes. I've read a couple of things online since running into this problem that seem to indicate it is pretty typical. But at any rate, I found one that seems to work fine. It is going to need a ring on it to keep the glassy kind of ring down, and for that I'm going to have to go find a tube ring. My tube rings all are bigger. They fit like 12AX7s and stuff like that. So I'm going to have to find a tube ring for it, but I think we're ready to go with it. Let's give it a test. Purple rain, purple rain.